This is Annie with the Perceptual Computing Lab, and this is the second part of a four-part tutorial series on getting some basic features of the Perceptual Computing SDK implemented in the Unity game engine. In the last tutorial, I covered getting the RGB feed into the scene, and in this one we're going to be tracking our hand locations. So to start, we're going to open up our main controller script, and we're going to add to this top section right here. First, we'll call a private pxcmgesture.geonode. Geonode is everything having to do with the hand locations. We'll call this user hand. Next, we'll make a private vector3 for our hand location. We'll call it hand pose. We'll make a public game object and call this hand icon. This is where we're going to be dropping the object which is tracking where our hand position is. A private bool. Bool is an on-off switch. And we're going to call this hand found. And lastly, we're going to call another private float. We're going to call this hand pose x. We'll only be making two changes to our start function. We're initializing more than just the color VGA this time, so we're going to put in pipe and pxcu pipeline.mode.gesture. Under all of this, we'll be adding user hand equals new pxcmgesture.geonode parentheses. So before we go into our update loop, we're going to create a function where all of these other functions start with void because we're not passing any data back. We're going to be starting this function with float. Let's call it remap, and then we're going to be feeding information into our function from our update loop, so we're going to give it some values to work with. Let's give it float, hand loc, float, old min, float, old max, float new min, and float new max. Now, the purpose of this is that while our camera is going to be feeding us coordinates to where it thinks it should be according to our hand, that's not necessarily going to be scaled to our Unity scene. So hand location is going to be where the values the camera is spitting out. Old minimum is going to be how far we can move before our hand goes outside of the frame, and old max, same in the other direction. New minimum is going to be how far we want our object to be actually moving in scene, and new max, the inverse of that. So we want our we want to process all of this and then return it back to our float. So we're going to start with by calling a return, and then we're going to, this is the equation we'll use, hand loc minus old minimum divided by old max minus old min times new max minus new min plus new min. And when we feed these values in, it should scale it to real world space. Now, if you remember from my last tutorial, we want to keep all of our work in our update loop between the acquire frame and the release frame. So under our old RGB information, let's script the rest of our stuff. So we want to say hand found equals my camera dot query geonode, and then let's say pxcm gesture, and then it's going to give us this shopping list. So we want our hand primary. All of these are going to be tracking different things, and this is going to be looking at the hand that we're putting up. It's going to be finding the center of the palm and spitting out information for that. And because it will be spitting out information, we need to say out and then give it a GeoNode object to export that into, which is our user hand. Now, the reason that we're putting hand found equals in front of this, which is a Boolean from up here, is it's saying if you see hand primary, then turn the Boolean to true, and if you don't see it, then turn it to false. And that's a useful function that we can call this limit the context of when we're tracking. So hand position x equals, and then we're going to feed that remap function we just wrote. So remap, and we want to invert it because sometimes it goes the other way. It does in this case. User hand, which is our GeoNode object, dot position world dot x, and then these are values that will probably change according to your scene, but these work well for me and they might be a nice starting point. We want the negative and the positive of 0.2, and then the negative and positive of 9. So that should remap properly into world space. And now we're going to say if you see my hand. So if hand found, then hand position equals new vector 3, and we're going to feed in that hand position float. And then we don't want it to go up or backwards in space, so we're just going to call 0 and 0 for our y and our z. Else, so this is saying you didn't find the hand, then hand position equals new vector 3, and we're just going to go screen width divided by 2, so just put it halfway on the screen and 0f, 0f. And now we're going to take this data and we're going to apply it onto our public game object that we called earlier. So hand icon dot transform dot position equals hand position. Now let's save it. And when we move back to our Unity scene, we'll click on main camera, which is where our script lives, and you can see we have a new public game object. So let's grab this red cube, which I've named handviz. You can tell because if you move it around, it moves. Select my camera and drag handviz onto this empty game object. Now when we run our scene, put my hand up, it sees my hand, it's tracking it. When I remove my hand, it goes away. So in this section, we gathered the position of our hand and translated it into an object's position. In the next section, we're going to control the object's scale using gestures.